Your next lesson is over 5.2. We're not going to cover everything in 5.2. We're going to hit the highlights and cover the things that I think that you'll see later and things that you may need to know how to do for the various programs that take this course. So the first thing that you're going to want to do is turn to page 214. And we're going to take a look at some of the different definitions that we have. The first thing that we have are the different types of angles. And you have acute angles, you have right angles, you have obtuse angles, and you have straight angles. And we probably need to make sure that you understand what an angle is. Back maybe when you were in elementary school and you did just a little bit of geometry, I'm thinking probably in 4th or 5th grade you learned about different kinds of shapes. And you probably learned about rays, and a ray has a starting point and then it goes on forever in one direction. Well, an angle is actually two rays put together, and they share a common end point. So the part that's in the middle between that common end point opens up, and the measurement of the opening is called a degree. So angles are classified by their degrees. A right angle is one that goes straight up and down. You will usually see this little square in the middle of it, and a right angle, the opening is measured at 90 degrees. So that opening is 90 degrees. An obtuse angle is one that is bigger than 90 degrees, but less than a straight line. So if you could imagine a straight line coming out here, this angle opens up this way, and it's bigger than 90 degrees in there, so it goes out further than the line that goes straight up and down, like this, the one we just drew here, and so it's more than 90 degrees. That's obtuse. A straight angle is a straight line, and a straight line goes out on both sides, because remember, an angle is two rays put together, so they share that common end point. They open up all the way. See, this one opens up all the way, and its measurement is 180 degrees. An acute angle, I think of this one as a cute little angle, is less than 90 degrees. So if this is the 90 degree angle, the acute angle opens up and is less than that 90 degrees. So this is the opening for the acute angle. So you've got those four classifications there on page 214. So less than 90 is acute, equal to 90 is right, between 90 and 180 is obtuse, and equal to 180 is straight. So those are your classification of your angles. You're probably going to want to get out a piece of paper and write these definitions down and make sure you understand them. Two other definitions that are in your book on page 214 are complementary angles and supplementary angles. And they just have specific definitions. If you're looking on page 214, supplementary angles add up to 180 degrees. So if I have a 30 degree angle, let's say that's 30 inside there, and I have one that is 150 degrees. If I add those two angles up, they add up to 180 degrees, so they are supplementary. Complementary means that they add up to 90 degrees. So if I had a 30 degree angle and a 60 degree angle, 30 plus 60 is 90. So the 30 degree and the 60 degree angle are complementary. Those are two of your definitions, so you're going to want to add those to your definition page. Other definitions that we have, when we put those two angles, those two rays together to form the angle, the point that they join together is called the vertex. So you're going to see that in your reading. That point that joins that angle together is your vertex. And we usually label angles that way. We might have an angle that has a vertex, and that point that's there, we might call that point A, so I could call that angle A. I might also label points on the rays, and so you label the angle based on making sure that the vertex is in the middle, so I could call that angle BAC, because the A is in the middle, or angle CAB, and I would be talking about this opening that's inside here. So if I say angle A, or if I say angle BAC, or if I say angle CAB, I'm talking about the same angle. Other definitions we might have, if we have angles that are put together so that they are joined at the same vertex, as long as they're across from each other this way, they are called vertical angles. So these two angles, the one that's in here and the one that's in here, are vertical angles. These two angles, the one inside here and the one inside here, are vertical angles with each other. So if you look, let's see, on page 215, it gives the definition of vertical angles. It says two angles for which each side of one angle is a prolongation through the vertex of a side of the other. Don't you just love math words? It just means that the angles share a common vertex and that they're across from each other this way. So, just when you're looking at the picture, as long as they share the vertex and they're across from each other. Now, these two are not vertical angles. See where the shape falls on your picture? Those are not vertical angles. These two are vertical angles. So you can look at the picture and figure out which ones are the vertical angles. So those are some of your definitions. Sometimes you will see two parallel lines, and I don't know if you remember, but parallel lines are lines that never cross, and I know mine are not that straight, but you will see two parallel lines, and then you will see a line going through them. That line going through two parallel lines is called a transversal. And when you put that transversal through there, you will see angles. I'm just going to label these like this so that we can talk about some of the definitions. But you have an angle in here, angle 1, angle 2, and so forth, all the way up to 8. You've got those 8 angles in there, and you can see, just based on what we've talked about, that 1 and 4 are vertical angles, and then 2 and 3 are vertical angles. 5 and 8 go together, they're vertical angles with one another, and 6 and 7 are vertical angles. So if I said list the vertical angles, I would say angle 1 and angle 4. I would say angle 2 and angle 3. I would say angle 6 and angle 7. And angle 5 and angle 8. They're these pairs that go with each other. And vertical angles have something in common. They share the same measurement. So if the angle 1 has a measurement of 30 degrees, angle 4 also has a measurement of 30 degrees. If angle 2 has a certain measurement, angle 3 has that same measurement. So vertical angles share that measurement. So let's take a look at this picture. Let's say that I knew that this angle was 60 degrees. Let's just make something up. And that's all I knew. That would mean that this angle was also 60 degrees because they're vertical angles. And then, if you look at this part, this is a straight line. So that means that that straight line is 180 degrees. So they're supplementary. So 60 plus whatever this angle is has to add up to 180. That means that this one is 120. And see, look, this is another straight line. 60 plus 120 is 180. This 120 is the same as this one because they're vertical angles. So they have these relationships there. Now this section has a lot of definitions in it, so I'm going to show you a couple more definitions here. We're going to go back to that same drawing that we've had with our two parallel lines and a transversal. And you just need to get these straight in your head. Let's start with corresponding. And we'll color that blue so that we can look at the places that they are. If I were to take this line and move it up and set it on top of this one, the angle that's in here would now be up here. They would be in that same spot. If I had one here and I move the line up, it would be in this spot. And that's the idea between corresponding angles. If I were to move one of the parallel lines so that it sat on top of the other one, wherever the angle is the same angle measure as where it's going. So if I had this one and I move this line down, this square would be right here now. So they would be the same measure. They're corresponding angles. That's what that means. So we're going to leave that as blue so that we can look at that drawing. Corresponding angles mean that they're in the same place if we were to move the parallel line. If I look at alternate interior angles, interior means inside. So I try to think of inside my drawing. That's inside my drawing. This is inside my drawing. This is inside my drawing. Inside. It's inside as opposed to outside. So I think of looking at my drawing as the circles are inside, the X's are outside. So alternate means different, across from, separate. So if I look at this one, alternate would be this one. So these two angles, these two circles right here, are alternate interior angles. So whatever this measure is, if it were 30 degrees, this one would also be 30 degrees. They're equal to each other. So alternate interior. Those are the ones that are inside. So this one goes with this one. This one goes with this one. They match up. They're the same measures. They're alternate interior. So if you think of the X's as being exterior, this one matches up with this one. Alternate. The ones opposite each other. This one matches up with this one. And that's how your definitions go. So we're going to look at some of the problems so that you can see what you're actually going to be doing.